Hello dear friends, welcome back to Physics Corner. Today's lesson we are going to discuss the types of forces. How many types of forces can be exist? Let's see. Due to the motion of body influenced by some forces. यही तो क्लासिकल मैकेनिक्स का मेन एम है ना कि motion of bodies influenced by some forces. Now, how many types of forces are there? As we know that according to the Newton's second law, F equals to m into a. ये आप सभी को पता है. Now देखिए one by one हम forces. The first force is constant force. First force is constant force. For example, F equals to m into g. आप भी बता सकते हो कि ये कांस्टेंट फोर्स क्यों है, क्योंकि यहाँ पे ये जो दोनों टर्म्स है m and g, the mass of that body remains constant and g is the acceleration due to gravity, which is also constant, having a value 9.8 meter per second square. Okay? That's why this force is called as constant. And another way you can say that this force is completely depends on the constant quantity. The force which completely depends on a constant quantity, that force are called as a constant force. Now see the second one. Position dependent force. Why it is called as position dependent force? If the force depends on the position, that force is called as a position dependent force. Example, f of x equals to minus of kx, where x is a variable which denotes the position of a body in a certain frame of reference, and minus k is nothing but the constant. That is nothing but this force is called as resistivity force, and that constant is nothing but a resistivity constant. Now see the third one, velocity dependent force. F of v equals to qvp sin theta, where q is the charge of that particle, v is the velocity of that particle, and p is the magnetic field in which that particle experience force. But B is constant. जो भी हमने magnetic field दिया है वो क्या रहेगा, constant. And charge of that particle also remains constant. That's why this force is completely depends on a velocity. ये एक एग्जांपल दे रहा हूँ, इसे कई फोर्सेस रह सकते हैं. Now fourth one, time dependent force. The force which will depends on time, that force is nothing but time dependent force, cos of omega t. These are the four types of forces. तो ये force के types. Now see, in the Newtonian mechanics, for the straight line motion of bodies, we know the kinematics equation. Now, using the constant force, the first one, it is constant force, we are going to derive that kinematic equation. Okay, तो ये हमारे पास F equals to mg, ये constant force हमारे पास है. अब इस constant force का यूज करके हमें kinematic equation निकालना. देखिए, as you know that according to the Newton's second law, F equals to ma. Now this is equation 1, this is equation 2. Equating equation 1 and 2, you get ma equals to mg. mm get cancel. In terms of acceleration, you can write dv by dt equals to g. Now shift this dt on the side. dv equals to g to dt. Now take the integration. Now see, on the left hand side you are integrating with respect to v. Therefore, initially velocity is u and finally v. And on the right hand side, you are integrating with respect to t. Initially time is 0 and finally something t. Now, integral of d is nothing but v. This is initial, this is final. Here, g is constant and take that constant outside of integral, and integral of dt is nothing but t. Now, you have to put the final and initial point. v minus u equals to g into t minus 0. v minus u equals to g into t. Therefore, v equals to u plus dt. This is the first kinetic equation which we have derived from the constant. Now, using this first kinematic equation, we are going to derive the second. Now, see, v equals to u plus dt. Instead of v, you can write dx by dt. Yes, change in position with respect to time. Now, shift this dt on the right hand side. U plus g into dt. Now, rearrange this term u dt plus gt into dt. Here, dx. Now, take the integration on both sides and put the limits here. You are integrating with respect to position, therefore initially position is x0 and after some time x. And t initially 0 after some time t. Initially 0 after some time t. Integral of dx is nothing but x. x0 x. Here u is constant because you are integrating with respect to t, and integral of dt is t. Initial, final. Here g is also constant. Integral of t is nothing but t square by 2, 0, t. x minus x0, first upper, then lower, first upper, then lower. Here I am taking one by constant outside, t square minus 0 cos square. This is the change in position. You can write the symbol s, that is the displacement ut plus half g into t square. This is the second kinematic equation. Now, we have to see third one. Third kinematic equation. As you know that acceleration is equals to dv by dt. Now, I am going to adjust dx here. Yes, I can write like this. Now, dx by dt is nothing but velocity, therefore dv by dx into v acceleration. Now, shift this dx on the right left hand side into dt. This implies v dv equals to a into dx. Taking the integration, initially velocity 0, finally v. Initially displacement x0, finally x. Integral v square by 2 uv. Here is a constant because you are integrating with respect to x, x0 x. This implies half outside v square minus u square equals to a x minus x0. But now, shift this 2 on the right hand side, v square minus u square equals to 2 times acceleration, and instead of this you can write the displacement sign s. This is the third kinematic equation. इतना सिंपल था कि kinematic equation में constant force यूज करके निकालना। अब देखिए हमने law of conservation of total energy भी देखा था। अब using the position dependent force, we will derive the law of conservation of energy. अब देखिए second, position dependent force, that is f of x. Okay. F of x equals to m into a. Yes, I can write here instead of acceleration. You can write dv by dt. Now adjust here dx by dt. and dx by dt is nothing but velocity, and the right hand side f of x. Move this here, f of x into dx and into v dv. Make an integration. Now on the left hand side you can see integral f of x dx is nothing but work done. Here m is constant, take outside, and integral v dv, initially u, finally v, and integral v is nothing but v square by 2 u v, half times m, v square minus u square. This implies half mv square minus half mu square. This is final kinetic energy and this is initial kinetic energy. Therefore, work done is equal to final minus initial kinetic energy. Now see, अब देखिए यहाँ तक सब ठीक था. Now F equals to minus of delta into V, and this F is nothing but position dependent. Now this is the del operator, d by dx plus dou by dou y plus dou by dou z, but here the force is only depends on x, that's why you are talking into this dv by dx. Shift this dx here, f of x into dx minus of d. I'm taking integration, this becomes work done. Okay, तो हमने पहले भी देखा था. Initially, finally, minus of v, u, v, for v minus u. Rearranging this term, we get u minus v. अब देखिए हमारे पास दो इक्वेशन है, ये और ये है. अब इसको हम क्या करना है, इक्वेट करना है. df minus dr equals to u minus v. अब देखिए इसको हम यहाँ पे शिफ्ट करेंगे, इसको इधर. df plus v equals to u plus dr. देखिए total energy is nothing but kinetic energy plus potential energy. Now final total energy is this, that is final kinetic energy and final potential energy, that is final total energy, and this is initial energy. That's why you can say that law of conservation of holds good when the force is position dependent. देखिए इससे ये कंक्लूजन निकल के आया कि law of conservation of total energy holds good when the force is position dependent. Okay, तो इस वीडियो में इतना ही. If you really like video, do subscribe to my channel and hit the bell icon for more videos like this. Thank you for watching. See you in the next.